All right, so where we left off yesterday, it was on problem 2, writing a system of equations. So here's the problem. One satellite radio service. Y'all know what a satellite radio service is, right? In your car, you have Siri or something like that. Sirius, I think is what it's called. It's called S-I-R-I-U-S, radio. Okay, so you pay for that. Your parents do. So if they don't pay for it, then obviously you don't have it. But sometimes when you buy a new car, it's provided for the first 6 months or something. That's what satellite radio is. It's kind of like internet radio, except you can get it through your car vehicle. So they're going to charge $10 per month, plus an activation fee of $20. That's radio service 1. Can you write a function rule for that? Well, just from that sentence, I should be able to write a function rule because it says it charges what? What are my costs? My cost for this service is equal to what? $10 per every month. So if I have it for 1 month, it's $10. 2 months is $20. Right? 3 months would be $30. So what am I doing to calculate the cost per month? I'm taking $10 and multiplying it by what? The number of months that I have the service, plus an activation fee of $20. So it's going to cost me $20 in addition to that. So if I'm going to write an equation for this, instead of writing it as cost in months, mathematicians are kind of lazy. They use variables like C to represent cost, the total cost. And instead of the number of months being written as the number of months, or the word months, I would write that as 10 times what? M. Right next to it, because if I put a number next to a letter, it means multiplication, right? Plus the $20. Okay? So let's write an equation for the cost of the radio service 2. What is that? It says a second service charges $11 a month. So what's this cost? It would be $11 times the number of months, plus an activation fee of $15. There's an equation for my second function. And does that model the table? For example, the cost for 1 month, if I plug in a 1 there, what's 10 times 1? Very good, 10. Plus 20, so that gives me 30. If I plug in a 2 for the number of months, it'd be 10 times 2, which is 20, plus 20, which is 40. If I plug in a 3, does it model my function rule? It should. 10 times 3 is 30, plus 20 is 50. Do y'all see how it models the table? Is this the right function rule for this table? Let's just verify it and make sure it works. If I plug in a 1 for the months here, 11 times 1 is... What's 11 times 1? 11 plus 15 is 26, right? 11 and 15 is 26. So what if I plug in a 2? For 2 months, it's $11 per month for 2 months, so that would be $22. So if I take $22 plus $15, that would be $37. And if you plugged in a 3 and a 4, it would all work out as well. So we do have the right function rule. Everybody agree? Okay, so what's the question asking? It says the information is given in the table below that models the function rule. Okay? And it also kind of gave me the initial cost and whatever else to come up with my function rule. So it's giving me more information. But what's the question asking? It doesn't even come up to the question until the last part. It says, in what month will the cost of the services be the same? So basically, when is the cost of service 1 equal to the cost of service 2? So whenever you were in 8th grade, y'all solved this problem by taking the cost of service 1 and substituting it in here, 10m plus 20. When is it equal to the cost of service 2? The cost of that service 2 is 11m plus 15. And then y'all solve that equation for m by using your 4 steps of solving an equation, which is step 1, to distribute, step 2, combine like terms, step 3, variables on one side, constants on the other, step 4, isolate the variable. Y'all remember that? We could solve it that way because that's all it's asking. When is this cost equal to this cost? So if I solve it that way, what would I get as an answer? Well, let's just solve it. So there's nothing to distribute. There's no like terms to combine. So if I got my variables on one side, so I'm going to subtract 10m, And I'm left with 20 on the left side because 10m minus 10m is 0. 0 plus 20 is 20. And then 1m minus 10m, or excuse me, 11m minus 10m is how many m's? 1m plus 15. See, that plus 15 is still there. Now, I almost have my variables on one side and constants on the other, except I got to get that constant over here on this side. So to get rid of a positive 15, what do? What you do to one side of the equation, you got to do to the other. So 20 minus 15 is 5. 15 minus 15 is 0, and 1m plus 0 is just what? 1m, and 1 times m is just m, so m would be equal to 5. Now, I know my answer algebraically is 5, but how do I solve this as a system of equations? Well, look, I could have solved that exact same problem by writing this as a system of equations in terms of y and x. Watch. My output, which is y, is equal to 10x plus 20. Do you agree? So why am I writing it in terms of x and y? I'm writing it in terms of x and y so I can graph it to solve. And I can't graph this in terms of c and n. This x, this y, this z is used for graphing. I cannot use these other letters for graphing. Because when I graph things in this calculator, I have a y-axis and I have an x-axis. So I have to identify which one is x and which one is y. You following, Hayden? Might want to close that and pay attention. Alright? So which one's x and which one's y? The output is y. The input is always x. What about this? This would be y is equal to 11x plus what? 15. We good? Now I have two equations. I can solve this as a system of equations to find out where they are the same. That's what I'm trying to figure out. When is the cost of one equivalent to the cost of the second one? And I can solve that as a system of equations because if my first equation is y is equal to 10x plus 20, and my second equation for my cost would be 11x plus 15, if I can graph these and find out where they intersect, that is an x value, which means the number of months in which the cost, which is my y value, the x and the y value is a point that they both share. So what is the x value that makes my y value equivalent in both equations? And that's the same thing as what we did here. When is the cost? When are the y's equal to the y's? What is the x value that makes the y's equivalent to each other? So to solve that, we could simply just plug it in our calculator and find the intersection. So let's do that. Let's go to home screen. Go to a new document. Don't save my last. And let's see when these are equal. So I have to add a graph. Two graphs on the same coordinate plane is what I'm trying to do. I can leave this in function notation. Why do I not change this to relation notation here? They're both in slope-intercept forms. So that's the same thing as y is equal to 10x plus what? 20. And there's the cost function. Do the same thing in the other one. You might want to plug this in because I know how to do it. I'm trying to help y'all. So go to tab and plug in 11x plus what? 15. And then find the intersection. Well, they look parallel, don't they? They're not. How do you know they're not parallel? This slope and this slope are really close to the same numbers, but are they the same? That's an 11, which is not the same thing as a 10. So they're not parallel. So how do I get this to fit on my screen? Look, I'm going to show you a new feature in your calculator that might help you fit it in there so you don't have to zoom out so much. Because whenever I zoom out, here's the problem with zooming out. If I go to zoom out, watch. So go to Window, Zoom, and zoom out. See, I have to zoom out to see the intersection. Otherwise, my calculator won't tell me what it is. If you don't see the intersection, it's not going to tell you. So I have to go to zoom out, and so I say, well, I need to zoom out up here somewhere. And then, oh, I still don't see it, so I'm going to zoom out up here somewhere. Right? And then I still don't see it because it might be even higher. It just looks like they become two lines on top of each other, right? So it's not easy to see. So I'd have to mess with my x's and mess with my y's. Instead of doing that, there's a faster feature to zoom into both of these, a little bit easier. Hit Menu, Go to Window Zoom, which is 4, and then do a zoom fit. Do you see that little screen right there? It's saying, hey, I'm going to try to fit these in the screen as much as I can, which is A, so just hit enter. Okay? And then it kind of fits it in the screen better. Doesn't that fit it in a lot better? It's kind of easier to see. It's still not great because they're so close to each other. But I can see that these are separated, right? And I can see that these are separated a little bit more. If I wanted to zoom in more, I can change my window just to be in quadrant 1 because that's the only thing that really makes sense in this. Why? Because I can't have negative cost, right? And I'm not going to have negative time. So really, if I'm graphing this, I'm only graphing in quadrant 1. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. I would only be graphing the positive time and positive costs. So if I wanted to mess with that a little bit more, I could. Let's just go ahead and change our window so we can get used to that. To be only positive. So go to Window, again, which is number 4. So I went to Menu 4. I'm going to show you how to mess with your window. So go to Window Settings, which is 1. And see how this is at negative 38? I don't want it to be negative. Let's just start off that at 0. And then my X max can be 40, that's fine. 41, whatever. And then let's go over here and let's change my Y min to be 0. I don't want it to be negative. So that the Y represents the cost, remember in the problem? And I'm not going to have negative costs. And this has it at 561. That's fine. Just leave it how it is. But let's just begin at 0 and 0 and then hit enter. Okay? So now I'm only looking at the positive values. Y'all see that? Okay. So that's a little bit easier to see what's going on. So what's going on in this problem is that initially the blue function is more than the red function. Right? Initially it is. And then at one point in time, they're going to cross, and the red is going to cost more than the blue. Okay? So at what point is that? At what point are they the same? So I go to Menu, I go to Analyze Graph, and I want to find the intersection to find out where they're the same. So I'm going to move that to the left of where I think the intersection is, hit enter, and then move it to the right, and then it picks up that intersection right there, which is at what? 570. Can y'all see that okay? If you want to move it around, I can, but it's right there. So my intersection is at 570. So what does that mean? Exactly. After 5 months, they both cost $70. So let me ask you this question. What if you had a membership, okay, for less than 5 months? Which would be the best deal? Would you rather have radio service 1 or radio service 2 if you're only going to keep this for 1 month, 2 months, 3 months, or 4 months? Which one do you think would be a better deal? Why? Okay, we can see that from the table, but why from the function rule? If it's 1 month. Well, if it's 1 month, the initial cost is $20, right? The initial cost of this one's only $15. So 15 plus the 1 month would be $26 compared to the $30. Okay, so radio service 2 would be cheaper up until what time? 5 months. Then let's say you wanted to have this service for a year. Which one would you rather do? Would you have radio service 1 or radio service 2? Anything after 5 months, what would be the best deal? Radio service 1. Why? Why is this one? Because it's cheaper, but why is it cheaper? The initial cost is more. The initial cost is more here than it is here. Why is this one cheaper after 5 months? Because of what? The monthly cost. The monthly cost is only $10 a month, and it only takes 5 months to make up that $5 difference. And then after that, it's going to be cheaper because the rate is cheaper per month. $10 is cheaper than 11 months. But it's not until after what? Month 5 that occurs. Those are the types of questions that you have to answer. Now, this is what you need to know. That little point right there, the coordinate 570, has a name. It's called the break-even point. That's the break-even point. That's when both equations are the same. It makes no difference what radio service you choose. Radio service 1 and radio service 2 are exactly the same. But if you go to the left of that point to a 4, x is 3, x is 2, x is 1, then you should use radio service 1. Anything to the right of that 5, like a 6, a 7, or an 8 month, you should use radio service 1 because it will be cheaper per month. If it's to the left of that point, I think I might have said that wrong, you should use radio service 2. So all of these right here would be radio service 2, right? And then all these points here would be radio service what? 1. And then at 5, it doesn't matter which one you choose because they're the same. I know I beat this down because I know this is a question that's going to be asked a lot. And we've spent 16 minutes going over this one problem. So do you think it's pretty important? Absolutely. Okay, so let's go to the next problem in our notes. Problem 3. We're looking at systems with infinitely many solutions or no solutions. Okay, so when do you have an answer to a system of equations that have no solutions or infinitely many solutions? Well, once again, if I were to graph these and they're parallel, that means no solution. If I graph these two lines and they're right on top of each other, that means infinitely many solutions because they share every point. So how do I know if these are infinitely many solutions or no solution? Well, I could simply put it in slope-intercept form and compare the slope and the y-intercepts. If the slope and the y-intercepts are the same, it has infinitely many solutions. If the slopes are the same and the y-intercepts are different, that means I have no solution. They'd be parallel. So I'm going to show you how to do it pencil and paper. So what's this slope in this problem? 1/2. And what's this intercept? 1. Figure out the slope and the y-intercept in that first equation. So how do I do that? I put it in slope-intercept form from chapter 3. How do I put that in slope-intercept form? Just get the y by itself. So I got to move that x over. And what happens when I move the x over? I'm left with a 2y on the left side because that x, I jump across the equal to sign and it becomes a positive x. So this is a positive x plus 2. Always put the x first. Because in slope-intercept form, remember it's in the form y is equal to mx plus b. Y'all follow so far? No questions? And then now what do I do to find the slope? Just from chapter 3, I divide by 2. Divide everything over here by 2. So y is equal to 1/2 x plus 1. So this equation in slope-intercept form is exactly the same as this equation. They have the same slope and the same what? Y-intercept. So my slope is my slope is 1/2 just like the other one. My y-intercept is 1 just like the other one. So when I graph these, my first one would have a y-intercept of 1 and the slope is 1/2. So I rise up 1, run to the right 2, connect the dots with your ruler. Do that in your notes. And then let's graph the second one. Here's the second one. It has a y-intercept of 1 and its slope is what? 1/2. So I rise up 1, run to the right 2. Rise up 1, run to the right 2. It's the same line. It falls right on top of it. So how many points do they share? They share that one, that one, that one, that one, that one. They share every single one of them. So this would be infinitely what? Many solutions. Thank you. Appreciate it.
You're welcome.
All right, let's look at problem B. All right, so look at this one. This one's already in slope-intercept form. Look how easy this would be to graph. What's the y-intercept here? 2, so I put a dot at 2. Right, and then use my slope to find other points. So my slope is what? 2. So I got to write that as a fraction. Isn't 2 the same thing as 2 over 1? So that's my rise over my what? Run from chapter 3. So to graph this with pencil and paper, I already have my y-intercept, so I have a point here on the graph. And then use my slope to find another point by rising up 1, 2, running to the right 1. Rise up 1, 2 to the right 1. Play connect the dots. And there's the graph of y is equal to 2x plus 2. Let's graph the other one. Where's this y-intercept? So I'll put a dot at -1 in my notes. You guys write it down. And then use your slope, which is the same slope too, to find another point. And my slope is to rise up 2, run 1. Rise up 2, run 1. Rise up 2, run 1. Are these ever going to cross if they have the same slopes but different y-intercepts? No, they will not cross. If they do not cross, there would be what? No solution. All right, so do you remember what this is called? What type of a system is this called from yesterday? Is it independent or dependent? So it is a dependent, consistent, or inconsistent? Consistent, because it has at least one solution. So that's a dependent, consistent system. What about this system? What would it be called if there's no solutions? It's not independent nor dependent. It is just what? Inconsistent. Okay? So make sure you know that. You might see that in the homework check. Alright, so let's go to the next problem, see if you understand this. How could we do this graphically in our calculator? Okay, to prove this in our calculator, we could do the same thing. Look, I could just go to my home screen, go to New Document, don't save my last one, and then just add a graph. Right, and graph these both on the same coordinate plane. So y is equal to, so it's already in slope-intercept form, so this would be real easy. I don't have to change it to a relation. It's just y is equal to a -x minus 3. Hit enter. And then graph the next one. So I hit tab. And then my second equation, my y sub 2, or f of 2 of x, would be equal to a -x plus 5. And then enter. See how those are parallel? They might not look parallel. Okay, I don't know. They might be a little bit off. I don't know if I can tell, but I can tell mathematically that they're parallel. See, because this right here, maybe one's just tilted a slight bit, and I can't really tell. So how do I prove mathematically here that they're parallel? They look parallel on the calculator, right? But how do I prove that they're parallel? The slopes are the same. Both of them have a slope of -1. But the y-intercept here is -3. And this slope is -1. But the y-intercept here is 5. So when I graph it, this is going to cross at a -3 and have a slope of -1. So it's down 1 over 1 like that. And this one crosses at a positive 1, 2, 3, 4, 5 and has a slope of -1. So that's down 1, right 1, down 1, right 1, like that. So I know that they're parallel because the slopes are the same and the y-intercepts are different. So what does this mean? A would have what? No solution. What about B? Well, look, B, let's just graph it in a calculator and see. Now, are both of these in slope-intercept form? No. So how am I going to graph these in here? Graph it as a function or as a relation? Relation. So go to your home screen, go to New Document, don't save my last, add a graph, and then we're going to graph this as a what? Relation. So I got to change this from function notation to relation notation by hitting Menu, Graph Edit Entry, go to number 2 to change it to a relation, and let's graph y equals 3x minus 3. Everybody understand how to put that in there? And then just hit enter. And then let's graph the second one. The second one is 3y is equal to 9x minus 9. It's so easy to graph that. I just hit tab and type it in exactly the way it's given to you. And your calculator's so smart, it'll do it for you. 9x minus 9. And they're right on top of each other. How do you know they're right on top of each other? typically it puts it right on top of each other right there. And you can see they're right on top of each other right here as well, because it's a blue and a red line, which ended up making a black line. You see that? So if there are two lines that fall right on top of each other, they have the same slope, the same y-intercept, which means that there are what? Infinitely many solutions. Okay? Now, I could prove that they have the same slope and the same y-intercept by taking that and put it in slope-intercept form. So if I had 3y is equal to 9x minus 9, put that in slope-intercept form. How do I do it? Just divide by 3. Just get the y by itself. 3 divided by 3 cancels out because that's 1. 1 times y is y. 9 divided by 3 is 3x. And then you have to divide this one by 3 as well. So what's a negative 9 divided by positive 3? Negative 3. Look, it's the same equation. See that y? See that slope or slope? The slope is 3. The y-intercept is negative 3. They're the exact same two equations. So when you graph them, they're going to fall right on top of each other, which obviously is infinitely many solutions. Which is what type of a system? Consistent and dependent. What type of a system is this? Inconsistent. Okay, here's the question in C. Before graphing the equations, how could you determine whether a system of equations has exactly one solution, infinitely many, or none? Okay, so if it has one solution, how do you know if a system has one solution? Okay? The slopes are what? The slopes are different. See, this is without graphing. If you look at a equation, and if you see the slopes are different, you know you're going to have one solution. Always. Okay? How do you know if you have no solution? Without graphing, if you're in slope-intercept form and you just look at the equations, how did I know in this one I was going to have no solution? Because what's the same and what's different? Exactly. So the no solution ones have the same slopes, but different what? Y-intercepts. So how do I know without graphing if I'm going to have infinitely many solutions? The equations have what? Same slopes and same what? Y-intercepts. Can y'all see that? These two equations right here, equation 1 and equation 2, when I put it in slope-intercept form, have the same slope of a 3 and a 3, the same y-intercept, same y-intercept. So when I graph it, it's going to be the exact same line. It crosses at negative 1, 2, 3, and has a slope of 3, 1, 2, 3 over 1. It's right there. When I graph my second equation, it's doing the same thing. It has a y-intercept of negative 3 and has a slope of 3. Rise up 3, run 1. Rise up 3, run 1. It'll be the exact same graph, which is right on top of each other. So that right there you need to know. That you will also use again in Algebra 2. I'm just giving you a system of equations and say, hey, y'all tell me how many solutions there are. And I'll take away your calculator and you just tell me how many solutions. 1, 0, or infinitely many. Okay? All right, let's just make sure we understand what we've done for today. We'll do the last part tomorrow. Let's solve this system by graphing. By far the easiest way of solving this is in our calculator, so let's do that and write our answer as an ordered pair because it's not an applied problem. So let's do this. I'm going to do this a lot faster now, so y'all keep up because we're kind of like doing homework problems now. So you've already been taught everything you need to know. So to graph this, I just go to Menu. Go to Home. Go to New Document. Don't save your laughs and add a graph. And I want to graph this as a function or a relation. So I go to Menu, Graph Edit Entry, graph it as a relation, and then graph y is equal to negative x minus 4. And then hit Tab, and then graph this 4x minus y equals negative 1. Right there. Just plugging it in my calculator as a relation. And then find the intersection by going to Menu, Analyze Graph, Intersection, which is 4. Move it to the left and to the right of that intersection. And what is my answer? Is it -1? Oh, I saw -4. You're right. It's -1, -3. So if you can't see it very good, because I didn't see it very good, just move it over. And you're right. -1, -3. And that's how we write our answer. All right, let's go to the next one. Use the information in the table to write a system of equations. Graph the system to find the point of intersection. What does the point of intersection represent? How could I come up with an equation for this? Find the slope and the y-intercept. Find the cost. The cost is y. Number of tickets is x. So to figure out y, what do I do to x? Well, what's the slope? What's it going up by? As these are increasing by 3 and 5. See, this is increasing by 3, this is increasing by 5, this is increasing by 28 plus 58 is an increase of 30. From 58 to 108, what's that an increase of? So 108 minus 58 is 50. So what is my change in y and change in x? Change in y over change in x. 30 for 3. Is that the same thing as 50 for 5? Yes, that's 10 is equal to 10. So what's my slope? 10. What's my y-intercept in this problem? Well, how do I find the y-intercept in this problem? Well, it would be the initial amount of the cost of the tickets. Okay? So if I were to graph this to find the initial amount, it says how much would it be for 1, right? And then how much would it be for 0? That's all I'm trying to figure out. So if I can come up with my function rule to find maybe if there's a service charge or something, how can I do that very easily? Okay, well, I can come up with a linear function that goes through all these points by doing a linear regression in my calculator would be one way, or I could just kind of work backwards. Right? If it was 1, how much would it be? If I was continued to decrease by 10, that would be 18. If it was 0, how much would it be? I would decrease by 10, which would be 8. You see the pattern in the table, how it's doing that? So with every 1 ticket, it's an increase of 8 because that's my slope. So my y-intercept here would be a 8. 1, 2, 3, 4, 5, 6, 7, 8. And my slope is a 10, so this equation would be nothing more than 10x plus 8. Or if you want to do a linear regression, you could have done a linear regression. It would have told you the y-intercept. It would tell you the y-intercept. But I think I can work backwards and figure that out. What about y'all? Like here, what's this increasing by? From 60 to 24, that's an increase of what? So 60 minus 24. Okay? So it's 36. And then from 60 to 120 is an increase of 60, as this is increasing by what? 3. And also by 5. So what's the slope? What's the change in y over change in x? 36 divided by 3 is 12, just like 60 divided by 5 is 12. So my equation in slope-intercept form, my cost is equal to $12 per ticket plus what would my initial cost be? Well, if I look at the pattern in the table, I can kind of decrease this by 12 each time. So 1 ticket would be $12 less than this, which would be 12. And 0 tickets would be $12 less than that, which is just 0, so it would be 12 plus 0. 2 times 2, or 12 times 2 is 24. 5 times 12 is 60. 10 times 12 is 120. So this equation is simply 12x, so there's no service charge. So graph the first one, graph the second one, see where they cross, and that's the point in which the cost for the tickets would be the same. So go to New Document, don't save my last, add the graph. Let's graph the first one, y is equal to, or let's graph the second one. Y is equal to 12x. Tab, let's graph the second one, which is, or the first one, y is equal to 10x plus 8. It doesn't matter the order in which you graph these. There you go. Now find out where they cross. Now they are going to cross. Why? The slopes are different. Y'all see that? But where? So let's go to Menu. Let's fit this into our screen by going to Window, Fit, which is A. And it's easier to see the intersection. So right now the blue is cheaper, and then at that point the blue is going to become more expensive. The red function right here is cheaper, or more expensive, I'm sorry, until that point. Then it becomes cheaper. So where is that break-even point? Go to Menu, Analyze Graph, find the intersection. Move that to the left of the intersection, to the right of the intersection. Where is that point? So what does that point mean? If you buy 4 tickets, okay, if you're ordering online, and 4 tickets, when you purchase at the door, the cost would both be how much? $48. So, 4 tickets cost the same $48 for both online costs and at the door costs. So make sure you explain in words what that solution means, what that intersection 448 means. Don't just put an answer 448. It would be 4 tickets cost the same, $48 for both online costs and door costs. Alright, last question and then we'll do some homework. One equation is the system is graphed at the right. Write a second equation so that the system is consistent, which means at least one solution, and independent, which means exactly one solution, and that solution is -1, 2. So the solution to this should be at a -1, 1, 2. Write an equation of a line that would cross that. It could be anything. Like, what would be an easy one? Just one that has a slope of -1. So if this has a slope of -1, what would the y-intercept be? Can y'all tell me? 1. And what's the slope of this line? -1. So what would be an equation for this? Y is equal to mx plus b. -1x plus b, which is my y-intercept. Isn't that the same thing as -x plus 1? So there's one equation. You could have infinitely many. We could find equations all day long. You could find one with the slope of -2/3 or whatever. Okay? But that would be an easy one. Y'all got it? Okay, so we're going to stop there and we'll finish this lesson up tomorrow. But your homework tonight is going to be a worksheet. I'm going to go ahead and give you that worksheet right now.